we are going to discuss today about modulus function, its graphs and simple properties along with the solutions. So many people they find it difficult, but this is very easy topic. So let us start with the definition. As we know, fx equal to modulus of x, also known as absolute value. It is running from, this function is running from R to R, that is real number to real number. This domain is a real number and the range is also real number. In fact, the range is from 0 to infinity, R being the codomain. It can be subdivided into this. It is equal to x if x is greater than or equal to 0, minus of x if x is less than 0. Okay, this is the definition. That is how the modulus function is defined. Okay, so we are going to draw the graph of it, and I want you to pay attention here. This graph is going to tell you many things. We are going to draw, let me take y fx equal to y. So we are going to draw the graph of y equal to x. That already we know y equal to x is a line passing through origin, dividing the first quadrant into two equal parts. But here this graph will not go beyond this point 0, because that is how it is defined. X is, we are drawing exactly this, y equal to x. So it will be right from 0, the value of 0 is 0 and the other positive things will map to themselves. So it is y equal to x. Now for the negative numbers, we're gonna draw y equal to minus x. So here comes the graphical transformation. Of course, otherwise also it can be drawn, but just I want to bring that concept also together here. I'm going to use the transformation fx going to f of minus x. This graphical transformation gives us how this graphical transformation works. कि y equal to fx का हमने ना y axis में इसका reflection ले लेना है. So all I have to do to draw y equal to minus x, I'll take the reflection of y equal to x, that is fx, into the y-axis to get this. So it becomes y equal to minus x. So these two graphs combined gives us y equal to modulus of x. Okay, y equal to modulus of x. Along with this, we need to learn a few more transformation along with some properties, simple properties, as the topic says. So first few property can be taken like this. For y equal to fx equal to modulus of x, some of the things we have to take care. Key modulus of x is always positive. Modulus of x less than 0 means if it is negative, somebody says, it will imply no solution. It is simply saying that there is no negative value, negative value x satisfying this relation. That's it. Okay. Two properties. Suppose we have to solve modulus of x equal to 2. What does this equation actually means? All it means is number of values of x, number of points on the number line, which is a line at a distance 2 units from the origin, from 0. Okay, And then obviously we know that there are 2 points which are at a distance 2 units on either way of 0 are 2 and minus 2. So modulus of x equal to 2 implies x will be equal to plus and minus of 2. Okay, this is what it means actually. Modulus of x equal to 2 means this. So in general, this first property is coming up. In general, if modulus of x equal to k for any real number, then we get x equal to plus minus of k. Okay. The next coming up property is related to this only. Suppose it is given like this: modulus of x minus 1 is equal to 3. To solve this, what does this mean? Okay, distance of the points. The points which are at a distance 3 units on either way of 1. So it will be on the right hand side, to my right, positive side will be obviously 4, and this way it will be 1, 0, minus 1, 2, minus 2. So ultimately this equation is telling us that x will be equal to minus 2 and 4 because they are exactly at 3 units distance from the number 1. Okay, so in general, if x minus a is equal to k for a number a greater than 0, the positive number, then obviously we must have x is equal to a minus k and a plus k. Okay. A few inequality property also we are going to take, which are of course related to this only. Modulus of x is less than or equal to a for a number a greater than 0. We'll always have x is lying between minus a to a. Again, the same concept being used. Suppose we have to find out modulus of x less than or equal to 2. So all we are looking for the number of points which are at a distance either 2 or less from origin. So these are the numbers which are represented by x. So minus 2 and 2. So again it is saying the same thing, x will be lying between minus 2 to 2. Similarly, modulus of x greater than equal to a will imply either x is less than equal to a or x will be greater than equal to a. Sorry, this is minus a. X is less than equal to minus a or x is greater than equal to a. It's the same thing now. It has to be greater than. Now modulus of x will be greater than equal to 2. So all we are looking for the values of x, that is the points, which are either greater or equal to 2 units from origin, that is this way or that way. That is exactly what this inequality is telling us. Okay, so these are the simple inequalities we need. Apart from this, we need some transformation, simple transformation of modulus. We are going to draw one by one. The first transformation we need is kind of this: how to draw the graph of y equal to suppose x minus 1. So to draw it, what we are going to do is original graph x minus 1. The critical point is at 1. So we are going to shift this graph to point 1. So eventually it will look like this. Okay. Had it been plus 1, it would have been shifted to minus 1. So this would have been the graph of modulus of y equal to modulus of x plus 1. The first type of graph we need this kind. Means the general is y equal to modulus of x plus a for a greater than 0. And the next kind we need y equal to modulus of x plus or minus a being a positive number. This kind of transformation, what we are going to do is the original graph, that is modulus of x. Suppose I am drawing y equal to modulus of x minus 1. So what we are going to do in this point 0, we are going to shift this graph to the critical point again. That is being, there are two critical points, but anyway, we are going to shift it to minus 1, the value of a. So ultimately, the graph will take a shape of this. So this one will become y equal to modulus of x minus 1. Similarly, modulus of x plus 2 will be, the original graph will shift 2 units above x-axis. It will take shape of this. So it will become y equal to modulus of x plus 2. The last transformation, last one transformation. With that we can go ahead with the solutions. The last transformation I want you to know is this. When fx transforms to f of modulus of x. I'll take one example. Suppose now we know how to draw modulus of x minus 2. Now, how do I draw y equal to modulus of x minus 2? So, all I need to know is, already we know how to draw modulus of x minus 2, that is, original graph will shift 2 units below the origin. This modulus of x minus 2. Now to draw modulus of x minus 2, all I need to do, the part of the graph which is lying below x-axis, we have to take the reflection on x-axis. It's this part, we're gonna take the reflection of this part on x-axis, so it will become this. And this part again lying below x-axis will take the reflection of this part on x-axis and it will look like this. And we'll discard this graph. So this one will be now modulus of x minus 2 equal to y. So this is the transformation. If y equal to fx was modulus of x minus 2, then we have transformed it to f of modulus of x by taking reflection of the portion of the curve or the graph which is lying below x-axis, taking the what do you call image of the curve which is lying below x-axis on x-axis. Okay, so this now we can solve a few questions. Okay, related to modulus functions. We're going to solve a few questions. So I'm going to take a few questions which I brought. Suppose we have to solve, modulus of x minus 3 plus modulus of x plus 1 is equal to 3. Now this kind of questions can be done in 2 steps. The first step, you have to remove the modulus, and the second step, to solve in the intervals, All I need to know is the critical points. Clearly here critical points are -1 and 3. Okay, -1 and 3. So -1 and 3 divides the entire number line into 3 intervals now. Now we are going to solve this modulus function into these 3 intervals. So when x is less than -1, then modulus of x minus 3 will give you 3 minus x, because it is coming with a negative sign. It will come with a negative sign. X plus 1 also will open with a negative sign to get minus x minus 1 equal to 3. So we are going to get minus 2x equal to 1. So x equal to minus 1 by 2. Now then, we have made the case x less than -1, and we have landed up in x equal to -half. Obviously it is not going to lie in the interval -infinity to -1. That is what the interval we have made. It doesn't lie there. -half is greater than -1. So no solution here. The next interval will be x is greater than or equal to -1, this interval, and less than 3. So here what will happen? Modulus of x minus 3 again will open with a negative sign to get 3 minus x, and x plus 1, since x is greater than -1, the critical point of x plus 1, that is -1, so it is going to open with a positive sign, plus x plus 1 equal to 3. So we are going to get 4 equal to 3, which is absurd. Implies no solution. So here also there is no solution. The last interval, when x is greater than or equal to 3. Here, this one will open with a positive sign. That also is going to open with a positive sign. So we are going to get 2x is equal to 5. So x equal to 5 by 2. But again, 5 by 2 does not belong to the interval which we have taken 3 to infinity. So here also it is no solution. So this is the way to solve a equation involving modulus. The 2 steps, we have to remove the modulus, and the second step we have to solve the entire equation in the interval given by the critical points. Let us take one more example so that we get a little more insight. Take one more question. Okay, let me take this. Second question. One more question before we go to a magical method actually. What I call it as BWM, Bah method. I'm coming to it. BWM. I'm coming to it. BWM, Bah method. So before going to BWM, let me solve one more. Modulus of x minus 4 plus modulus of x plus 4 equal to 9. Okay. Again here the critical points are obviously -4 and 4. So it divides the entire line, number line into 3 intervals. So we'll walk on one by one. X is less than minus 4. This one will open with a negative sign. 4 minus x. That also going to open with a negative sign. So I'm going to get x equal to minus 9 by 2, which is minus 4.5, clearly belonging to the interval we are taking. So it is a solution. The next interval here, x is greater than or equal to minus 4, less than 4. X minus 4 will open with a negative sign, that is 4 minus x, and x plus 4 will open with a positive sign, x plus 4 equal to 9. So 8 equal to 9, which is absurd. So implies no solution here. The last interval, x is greater than or equal to 4. Herein, x minus 4 will, modulus of x minus 4 will open with a positive sign, so is x plus 4. So we are going to get 2x equal to 9. So x equal to 9 by 2. 9 by 2, we have made the interval x greater than or equal to 4, and it is 9 by 2, 4.5, which is lying there. So it is 4 to infinity. Therefore, we have a solution this time. X belongs to two numbers, minus 9 by 2 and plus 9 by 2. Okay. Now, as I have promised, I am coming to the BWM. That is what I have given the name. This is the graphical solution of this. Okay. Let me start with this only because it is already written. So let me go with it. How to solve this equation using graph? Wow method. To solve it graphically, all I need are critical points. So critical point का खेल है भाई. Critical points are minus 4 and 4. First of all, we'll calculate what are the values at these critical points. Minus 4, we are going to get 8. And plus 4, also 8. To solve it graphically, we'll take this entire left hand side as y and this one as again y. So all we are doing is we are solving two simultaneous equations, y equal to fx1 and y equal to fx2. Where they will intersect, that will give us the solution. That's it. That is the idea behind it. Okay, minus 4 we are going to get 8 and plus 4 also we are going to get 8. So minus 4, say 4, we are going to get a graph like this. Now less than minus 4, x less than minus 4. So what y will become? Less than minus 4. Less than minus 4. This one will open negative 4 minus x. That one also open in negative minus x minus 4. So I'm going to get minus 2x. So, and clearly this one is suggesting us the slope is negative, so it will go like this, and this curve is y equal to minus 2x, and when x is greater than or equal to 4, both will open with a positive sign, so y will be equal to x minus 4 plus x plus 4, you get 2x. So again, slope is positive, so it will look like something this. Now then, We are looking for y equal to 9 now. Y equal to 9 will be something somewhere here. Y equal to 9. This is the line y equal to 9. So I am looking for those values of x where y equal to 9 will intersect the entire graph. That is y equal to modulus of x minus 4 plus modulus of x plus 4, which already we have drawn. I say this y equal to 9. Put here y equal to 9. So we'll get x equal to 9 by 2. And here, again this line is y equal to 9. So put y equal to 9 here. We'll get x equal to minus 9 by 2. And clearly, at no other points, this y equal to 9 is going to cross this left hand side of the graph. So there are exactly two solutions. One is at minus 9 by 2, the other one is plus 9 by 2. That's it. Okay, let me take one more question like this. Let me take one more. Okay, I hope you have understood this. Let me solve this. X minus 3 modulus plus x plus 2 modulus of x plus 2 minus modulus of x minus 4 is equal to 3. I am taking three functions, three absolute value functions, sum or difference of 3. It doesn't matter. So I am going to solve it graphically. Yeah, that is the best way of doing it. Of course, we need to know both the ways, algebraically by checking out the intervals as well as graphically, the BWM, wow method. So we are going to plot first the critical points in ascending order. Critical points are minus 2, 3 and 4. First of all, we'll try to find out again. So to draw the graph, we'll take this one as y and this one as y, left hand side and right hand side. So y will give you at minus 2. At minus 2, I'm going to get here 5 and here 6. 5 minus 6 minus 1. At 3, I'm going to get 5 from here and 1 from here. 5 minus 1 is 4. And at 4, this one will become 0. Here 1 and here 6. 6 plus 1, 7. So the graph will be something like this. Now we need less than minus 2. What will happen to left hand side? Less than minus 2, y equal to less than minus 2. This one will open negative. That one will open negative. That one also will open negative to get positive. So all I'm going to get is minus x minus 3. So y equal to minus x minus 3. The slope is negative. So the graph obviously will be something like this. For x greater than 4, y will be equal to, from here, this one will open positive, x minus 3, x plus 2 will be positive, minus x plus 4. Y equal to x plus 3. Again, the slope is positive, so the graph will something like this. Y equal to x plus 3. Okay. Now then, the right hand side is x equal to 3. So x equal to 3 is somewhere here. X equal to 3. Not x equal to 3, sorry, y equal to 3. Y equal to 3. This cutting these two lines, the entire graph in fact, at 2 points. So we are going to have two solutions. Now what are they? What are those values? So for that, already I got this equation of this line as this, y equal to minus x minus 3. And I need this equation of this. So this part of the graph is lying between minus 2 to 3. So we have to check left hand side between minus 2 to 3. So when x is greater than equal to minus 2 and less than 3, left hand side greater than equal to minus 2, so first inequality will open negative, next one will open positive, third one will open negative, which is equal to y. So I'll get y equal to plus 1, y equal to x plus 1. So this one is y equal to x plus 1. Now this one is y equal to 3. So put y equal to 3 here. So x equal to y equal to 3, x equal to 2. So this is one solution. And put here y equal to 3 again to get x equal to minus 6. This is the second solution. There are two solutions. This belongs to minus 6, 2. So this is how we are going to solve. Okay. Okay, let me take one more question. One more question. This time we are going to take one inequality. Okay. Suppose till now we are solving with an equality sign. So let us solve one question with an inequality, and let us check what will happen. It is nothing going to change really, if you ask me. Okay, let me take one more question, then we'll go to a few questions. Very, very good questions, legendary questions as they call it. Okay, so let me take this. Modulus of x minus 3 plus modulus of x minus 7 is greater than equal to 12. Obviously, as I said, you need to know both the methods clearly. Algebraically, you need to know how to solve it algebraically, and obviously you need to know how to solve it graphically, the BWM method, wow method. Because the graphical method is so very important, because once you see it, what is happening, it's become very easy. Okay, that's the whole point. Okay, we are going to draw. First of all, we'll draw for equality only. Equality, we are going to draw the equality. Critical points are 3 and 7. Okay, at 3, we're going to get 4. At 7, also 4. So this is what the graph will look like. Now less than 3. When x is less than 3. Less than 3, so left hand side will take as y. Y will be equal to less than 3, it will open with a negative sign, 3 minus x. That one also will open with a negative sign. So minus 2x plus 10. Slope is negative, so the graph will take a shape like this. We need the rough sketches, it need not to be exact. Okay, for greater than 7, again left hand side, for greater than 7, y will be equal to, this one will open with a positive sign. That one also is going to open with a positive sign. we're going to get 2x minus 10. And slope is positive, so it is going to give something like this. So it is y equal to 2x minus 10, and this one is y equal to minus 2x plus 10. Now we need y equal to 12. So while y equal to 12, this will be a line parallel to x-axis. Okay, this is y equal to 12. Okay, and don't get emotional. This 4 is there, 12 is there. Okay, this is a rough sketch only. So y equal to 12. So we are going to find first where they are going to be equal. So put y equal to 12. So this one will come what? Y equal to 12. Actually the graph is a little bit wrong, because this one will come negative, so it will be somewhere here. Okay, this y equal to 12. This point is 12. Okay, so put y equal to 12 here. 12 minus 10 minus 1. So this point will correspond to the value x, which is equal to minus 1. Okay, now put y equal to 12 here. 12 plus 10, 22 by 2, that is 11. So this point will correspond to a value of x, which is equal to 11. Now what we are looking for? This expression greater than or equal to 12. So all I care is this part of the graph, beyond 11 and beyond minus 1, this way. So ultimately x minus 3 modulus plus x minus 7 modulus greater than or equal to 12 is giving us the values of x which are either less than or equal to minus 1, or x is greater than or equal to 11. So x belongs to minus infinity to minus 1 closed, near 11 to infinity. As easy as that. Okay, let me take another question, which is a legendary question, as they call it. Okay, with the same concept. Okay, let me take this. The question is, let modulus of x minus 2 plus modulus of x minus 3 plus modulus of x minus 5 is equal to lambda. Find the number of values of lambda such that find the number of values of lambda such that the equation has one solution. Okay, this time they have given right hand side lambda. How to do? Let us draw the left hand side first. The critical points are what are the critical points? 2, 3 and 5. 2, 3 and 5. Okay, then what to do? We'll check the values at each of these critical points of the left hand side. So at x equal to 2, I'm going to get 1 plus 3, that is 4. At 3, I'm going to get 1 plus 2, that is 3. At 5, we are going to get 3 plus 2, 5. Oh, good. Somewhere 5. Okay, so the graph will look like obviously like this. Okay. Now for x less than or equal to 2, left hand side less than or equal to 2, so y will be equal to, this one will open with a negative sign, 2 minus x, that one also will open with a negative sign, that one also will open with a negative sign. So like it is minus 3x plus 10. So slope is negative again. The graph will be something like this. And for x greater than or equal to 5, y will be equal to greater than or equal to 5. All will open with a positive sign. So x minus 2 plus x minus 3 plus x minus 5. So 3x minus 10. So again slope is positive. So it's going to be something like this. Y equal to 3x minus 10. And this one is y equal to minus 3x plus 10. This is the graph of the left hand side. Now let's see what we are looking for. The value of lambda. You say this one is y equal to fx1 and this one is y equal to lambda. So y equal to lambda will be a line parallel to x-axis. So all they are asking us, if I draw a parallel line parallel to x-axis, it will intersect exactly at one point. What that point would be? So obviously from this graph there is only one parallel line parallel to x-axis which will cut the graph exactly at one point. That is this. What is this? This is lambda equal to 3. As simple as that. Okay. So this is the solution for that. This question again can be manipulated. It can be, what do you call it? It can be improvised to another question. Suppose somebody asks me the same question. Find the number of positive integers less than 15. Find the number of positive integers less than 15 such that the equation has two roots. Earlier we have asked one solution, now they are asking for two solutions. Now you see two solutions. Obviously, what we must get, this value of lambda has to be greater than, find the integral values they have asked, no? Here in the second question. So value of lambda to get more than one equation, more than one solution. So it should be something like this, right? So lambda should be definitely greater than 3, and they have already said that has to be less than 15. So all I need to find the number of integral value of lambda which is less than 3 and 15. That is 4, 5, 6 till 14. That is number of values they have asked. So number of integral value are 11. That's it. Okay, one last question for today. Okay, this is a very nice question, and let me tell you, you are going to enjoy this question, this coming up question. Okay, simple but a very tricky question. Legendary question is this. Legendary. Okay, the question is, find the number of solutions of the equation this x minus 2 modulus minus 2 co-modulus minus 2 co-modulus minus 2 co-modulus equal to 2. Okay, modulus, another modulus. Okay, we have to find the number of solutions of this equation. See, if you were going to do it, obviously it can be done by algebraically also, but it will be a really very tedious job. Okay, that's why I'm saying that you need to know both the method, especially this BABA method, graphical method. Once you see it, it becomes very easy. Okay, so let us do it graphically. For solving it, let me bifurcate this solution into some steps. Okay, step 1. So we'll start with this part, modulus of x minus 2. You know this graph, modulus of x minus 2. So let us go for one step ahead. Modulus of x minus 2 minus 2. What will happen? Modulus of x minus 2, 2 steps below. So it will be something like this. So this is what modulus of x minus 2 minus 2 is. This point is, here it is 2. It came 2 units below, so it will be minus 2. If I take the y-axis somewhere here, this point is minus 2. Okay, now we need modulus of x minus 2 modulus. So modulus, that time we have learned. So if the graph has some negative portion, make it positive, take the reflection on x-axis. So the reflection will be something like this. Okay, so this point is minus 2, this point will become 2. Okay, and we have to discard this. So this is now modulus of x minus 2 minus 2 ka modulus equal to y. Okay, suppose the question was up till here and we are looking for the number of solutions. This one is equal to 2. Suppose this question is modulus of x minus 2 minus 2 modulus equal to 2. Then what we would have done? We would have done this graph, then y equal to 2. Y equal to 2 obviously will pass through this. This is wrong. And clearly we are having 3 solutions. I want you to observe one thing. When there are 2 modulus, then there are 3 solutions. Okay, 2 modulus, 3 solutions. Let us go for one more step. Let us go for the next. Till here. This one, then minus 2, then modulus. It's this exact thing will come 2 units below. Then we'll take reflection on x-axis. Getting it, I guess. The entire thing will come 2 units below. 2 units below. Okay? The entire thing will come 2 units below. So it will look like this. Is it? Yes. Okay. This one will be the graph of now y equal to modulus of x minus 2 minus 2 modulus minus 2. Now we have to insert one modulus. So the moment I am going to insert one modulus, what will happen? This negative part of the graph will become positive. Just take the reflection and discard the negative part. Okay, this all values are 2. Okay, so if I now go back to the question, equal to 2. So y equal to 2 will have something like this. So how many solutions we are getting? 1, 2, 3 and 4. This was this. Now you see number of modulus is 3. We are getting 4 solutions. So obviously by going this way we can obviously see that how many modulus? 1, 2, 3, 4, 5. So this one will have 6 number of solutions. Please try this out. Okay, so that's it for today. We have discussed a few questions related to modulus, how to solve it graphically and algebraically also. Okay, so if you have, share, and please obviously comment how was it and how can I improve on my teaching. Okay, thank you, bye.